Well, good morning, everyone. It's happy Monday for you. It's actually a Friday for me, because I know I said it was Friday on Friday, and I had my. But how can it be Friday? I haven't got my Norwich. We live in this funny world, don't we? As teachers, we have to live in a different day. So on Friday, I do Monday, which is all a bit strange. And then I have my weekend off, which is nice then. But right now, I'm thinking Monday now, Monday. Anyway, I blather on. This was sent home with you. Now, I wasn't there when you were given it because I was off the last day of term, but it might not look like that. It might look like this. There's your first question, right down that inequality. You were given that paper to go away with and have some fun with over Christmas, and we thought by now you'd have come back and all of that stuff. So, what are we going to do about it? Well, I would still like you to have a go at that. Some of you will have had a go at it, some of you won't. I will, next week, starting on Monday, go through that. I'm not sure how many lessons it'll take me. It might take 2, it might take 3. I want to go through it fully, but there's only a point in doing it if you've done it. So when I want you to be ready to be able to mark your own and to pause the video when necessary just to fill in some working. But I'm going to work through it as if I was in the exam myself, talking through what I'm doing. So it'll take a while, but if you play all of the video and listen to it all and take notes, then it's a big learning opportunity. If you don't, then it's not. Now, I do know from looking at some of my YouTube statistics, we're meant to be on stream now, but I'm putting it on YouTube as well, because I know some people have issues with stream in terms of sound too, and it means you can go back to it whenever. But I know from looking at that the average amount of view time is about 60% of any of the videos that I put up, which saddens me a little. And it does mean that some of you are obviously missing out on some bits that may be there. So this is something where those videos won't take you a full hour each day. So I want you to make sure that you are pausing it and you do get the most out of them when you get there. And you've had a go at it before. So you've had a week's notice. Next Monday, I will be going through that. All right, now it's time to crack on. Before we get immersed into the main event for today, which is going to be nth term of quadratic sequences, a bit of a toughie. Just want to have a quick look at this start that I gave you the other day, a knight's tour, so a knight moving around the board. Now you can see I have not finished this, and the sharp-eyed amongst you will spot that I've got in a bit of a pickle in places. I reckon I've sorted this corner out now. So I was using pencil at first and then inking in anything I was sure about. I thought I was sure about these, but you'll notice that 91 is inked in already in the puzzle, and it's there. Now I can't cheat unless I stump up the money to go online and pay the newspaper for looking at it. So I'm going to work this out myself at some point. So the 90 and 91, the blue ink is ones which aren't there. These ones are definitely right. Not totally sure about the 27 and 28 yet. I think they probably are. I think the 28 has to be that one. Yes, oh, unless we went 27, 28. So it is possible. Yeah, so those 4 are not as they should be. These ones are. I've inked over them in black where it was blue. But I'll be very interested in if any of you beat me. I'm not going to go through it now. At some point in the future, I will have done it, and I will share it with you. Right, so I nearly called it seriously sensational sequences, finding the nth term of a quixotic quadratic. But even I have limits of ridiculousness, folks. So I've held back just about. Right, so we're looking at quadratic sequences. What are quadratic sequences? Well, they are ones that are linked to, well, quadratics are about squares, so they are linked to square sequences. So what is the sequence of square numbers? That's the place to start. Pause the video and write them down if you can. The square numbers. You should have 1, 4, 3 squared is 9. 4 squared is 16, 5 squared is 25, and so on. Now, what's significant here? Well, they are getting from one to the next is +3. Whenever you're looking at a sequence, the first thing to do is to look at the difference between each number and what's happening finding the pattern is what it's all about. And here we find that the difference is growing by 2 each time. So square numbers, their difference grows by 2 each time. Now the nth term is the code that allows us to get anywhere we like. If I was going to go for the 10th square number, I know that that's going to be 10 squared. The 3rd square number, I know that's going to be 3 squared. The 5th square number, 5 squared, and so on. So the nth term, n, is always the number, the term number that you are looking for. So what do we have to do to n to get the sequence? And in this case, we just have to square it. So the nth term for this sequence of numbers, now I should have said 36, shouldn't it? Okay, is n squared, because whichever term you want, you just square it. Now everything we look at today is going to be related to their numbers. Alright, there's an nth term. How about going the other way before we start? Find the first 5 terms in the sequence. So how would you do that? Pause the video and have a go. Right, now one way you could do it is you could start by saying, well, n, that's going to be 1, 2, 3, 4, 5 for the first terms, because it always will be. N squared would be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 2n squared will be these numbers doubled. 2, 8, 18, 32, 50, just doubling those. 2n squared plus 3, just about squeeze it on the bottom here, will be 2 plus 3 is 5, 8 plus 3 is 11, 18 plus 3 is 21, 32 plus 3 is 35, 50 plus 3 is 53. And if you were asked to do that in a calculator paper, all you would do is this. You would say menu, table like we did the other day, which is number 3, and then it says fx equals, and we would just put in 2. Instead of n, we would use x. Where's x there? Alpha x squared plus 3 equals, forget about the function g, we're starting with 1, we're going to 5. That is the first 5 sequences. Press equals, and it gives us 5, 11, 21 and 35. 11, 21 and 35, and if I just go down 1 there, it's also got 53. So you can find them all that way too. Now what we're going to be doing is we're going to start looking at some sequences, and we're going to be reversing that process. So how do we do that? We're going to use 1 or 2 little tricks to help us do it. Right, here's our sequence of numbers: -3, 6, 21, 42, 69. No sniggering, you know who you are, your name begins with O, stop it. So we are going up in however many's. Right, pause the video, do what you can. In fact, do a little bit more than you think you can. So, from -3 up to 9, the difference is, up to 6, the difference is 9. From 6 to 21, the difference is 15. From 21 to 42, the difference is 21. From 42 to 69, the difference is 27. Now, what we need to do with quadratics is look at the second difference. And that would be the difference between 9 and 15, which is 6. The difference between 15 and 21 is 6. The difference between 21 and 6 is 27. The second difference equals 6. Now that links it to n squared. if the second difference was 2, it would link directly to n squared. But because the difference is getting by more, that's going to be a factor of, for every difference of 2, you get an n squared. So what we have to do is we divide 6 by 2, and that tells us we're dealing with 3n squared. So 3n squared is going to get you a mark, definitely. Right, in order to do that, we now need to think about our what 3n squared is. So first up, I'm going to say n equals 1, or n squared. We can do n squared in one go, can't we? And we list out our square numbers. Then we say, well, that's okay, but I know it's to do with 3n squared. So we multiply everything by 3. 4 times 3 is 12. 9 times 3 is 27. 3 16s are 48. And 3 25s are 75. Great. Now that is not what we want yet. So at this point, what I do is I put a little gap below and I write out my original sequence. Again, -3, 6, 21, 42, 69. And I look to see what I have to do to get from here to here. So I'm looking at the difference between 3n squared and my original sequence. What is that difference? Well, from 3n squared, I am taking 6. 3 takes 6 gets me to -3. 12 takes 6 gets me to 6. 27 take 6 gets me to 21. 48 take 6 gets me to 42. 75 take 6 gets me to that. Therefore, I can say that this sequence here is 3n squared, and because I'm doing the same thing every time, it's 3n squared take 6. Right, so here's our next one. Often it is only 4 numbers they give you, because that's all you need, to be honest. It'll save us a bit of work. Pause the video, do as much as you can. You might get all the way there, although this one's a bit more complicated than the last, but we have done it before, so you may manage it. Right, so 9 to 23 is 14. The difference of 23 to 45 is 22. From 45 to 75 is nice and easy, that's 30. But we're bothered about the second difference. So the difference between the differences, 14 to 22 is 8. And 22 to 30, that's also 8. That's good. That means it's a quadratic sequence. So the second difference equals 8. And then you always get a mark for doing this. Divide that by 2 means we're dealing with 4n squared, plus or minus something. So the next thing to do is to generate 4n squared. Do not try to do everything all in one go. So I would say the more you can say, right, I'm going to deal with, I know that n is 1, 2, 3 and 4. N squared is 1. You don't necessarily need that, but it does help make a difference in a moment. 4, 9 and 16. But we want 4n squared, so 4n squared is going to be 4, 16, 4 9s are 36, and 4 16s are 64. And now we do what we did before, and we get our original sequence, and I'm going to put that down here, 9, 23, 45, 75, and I'm going to look to see what I have to do to 4n squared to make this sequence. So from 4, I'm adding 5. From 16, I'm adding 7. From 36, I'm adding 9, and 64, I'm adding 11. and I have to add this purple sequence on to the 4n squared, onto the green one. So this is actually this is where people often get totally sort of bamboozled. But 5, if I asked you for the nth term of 5, 7, 9 and 11 as a linear sequence, all you do is say, what's the difference? The difference is 2, isn't it? So if the difference is 2, that means 2n. But on the first term, we need 5. 2n is going to give us 2, 4, 6, 8, isn't it? We have to add 3 to each. So 2 plus 3 is 5. So 2n plus 3 generates that sequence, and we add that to our 4n squared. So our final answer is, so 4n squared, add 2n, add 3. Right, pause the video, have a go at this one. I've told you everything you need now, so I'll go through this one in a moment in a slightly briefer way. So you should have got that the second difference is 6, and then if we do divide 6 by 2, we are talking 3n squared. So now what do you do with that? Pause the video and keep going. So that should get you to 3n squared being 3 12s, 27, 42. Then you should have written these down below. Now I'll go through this bit again in detail. We want the sequence that you add to 3n squared to get 0, 4, 14, 30. So 3 take 3 is 0. 12 take 8 is 4. 27 take 13 is 14. 42 take 12 is 30. That doesn't look right. And if it doesn't look right, then we have to go through here. Now this is going, that's 5 bigger, that's 5 bigger. So we would expect this one to be 5 bigger. So what's, oh yeah, 16 times 2 is 32, times 3 is 48. So there's my mistake there. And then 5 more than that, yes, so it's now 18 down there. So here I've got a gradually growing amount of negative numbers. So I've got all falling sequence. So I now need to find the nth term of this. Now because it's getting smaller by 5 each time, that means negative 5n. And then you've got to think, what do you do to negative 5 to get negative 3? You've got to add 2 to that, because negative 5 times 10 will be negative 5, negative 10, negative 15, negative 20. Add 2 to each of those and you do get those numbers there. So we've got negative 5n plus 2, which needs to be added to your 3n squared bit. So at this point here, we can say that this sequence equals 3n squared, take 5n plus 2. Hope that helps a little bit. Right, I'm going to give you one that I want you to have a go at and upload to me as soon as you can, and then I'll feed back on to you either next lesson or maybe the one after, just to give a bit of time for me to see it and then to come back to you, and then we can just review it. And the sequence I've got for you is an absolute beauty to have a go at. So it's negative 1, 18, 47 and 86 are the first 4 numbers of the sequence. So you need to find the nth term of that. Start off by finding the second difference, and we'll see how you get on with that next time. Cheerio, folks.